Hello everyone, welcome back. Here is vanAmsen with another live coding challenge. So today we are diving deep into an interesting algorithmic problem. Is it a power of 4? And we'll be exploring two distinct approaches to solve this. So make sure to stick around till the end. So let's get started. The task is really simple. So given an integer n, we need to determine if it's a power of 4. So sounds straightforward, right? But there is a twist. We will be solving it using bit manipulation. So let's look at an example to clarify. So if our input is 16, so let's write it down. For example, 16, output is true. Why is this? Because 4 to the power of 2 is 16. So our function is true. So now how do we do and determine it programmatically? So for our first approach, we will use a combination of checks. So first, we will ascertain if the number is a power of 2, and then divide deeper to figure out if it's power of 4. Let's start implementation. So check if the number is positive and a power of 2. So if n greater than 0, n minus 1 equals 0, initialize a count for trailing 0 position after rightmost set bit. So 0 count 0 and loop until we have only the leftmost bit set. So for n greater than 1, 0 count plus plus, and rightmost shift the number to check the next bit. So n shift 1. Let's dive deeper. And then if the count of zeros is even, then the number is a power of 4. So return 0 count to 0, and if not power of 2 or not positive, return false. So otherwise we return simple false. So we have implemented it in Go. So now let's run it to verify if it's working. So hopefully it will. Yeah. So as mentioned previously, n16 power of 4 true, and 5 is not power of 4, so false. So what did we do here? So first we check if n is a power of 2. Then we count the trailing zeros. And if count is even, voila, it's power of 4. So let's submit it for unseen test cases to verify it's working. So yeah, as you can see, it's working, and runtime is 0 millisecond. We beat 100% with respect to runtime, and also with respect to memory 77. So all good. Now let's go to description and clear the window and wait. We have a more optimized solution. So instead of counting zeros, why not use a mask to directly check the position of the set bit, and let's dive into the second approach. So also we will implement it in Go. So first, define a mask with bits set in position corresponding to power of 4. So mask will be 0, 5, 5, 5. 555, yeah. And then check 3 conditions. So first, the number is positive. Second, the number is a power of 2, only one set bit. And 3, the only set bit is in position corresponding to power of 4. So return n greater 0 and n minus 1, 0, and mask n. So 3 conditions. So simple implementation. So without comment lines, it will be just 2 lines of code. So let's check if it's working. So hopefully, yeah, all good. Same case, and 16 true. So yeah, it's easy, but it's always good to know some tricks like bit mask manipulation. So one of my favorite. So let's submit it for unseen test cases as well to see if it's working. And yeah, all good. So basically also beating 100% runtime milliseconds. But yeah, for other programming languages, second approach is faster. Yeah, because it's used direct math to calculate, so it's really efficient. And this mask, bit mask 55555555, has set bits in all the position where a power of 4 would have its only set bit. So if our number and the mask give us back our number, then we are certain it's a power of 4. So yeah, so we have tested, all good, so perfect. Both solutions passed our test, and it's always fascinating to see multiple ways to tackle a problem, especially with a bit mask. And that's wrap up today's session. I hope you found it insightful, and remember, understanding the logic behind the solution is just as important as the solution itself. So if you enjoyed the video, don't forget to hit the like button, share, and subscribe for more coding challenges, tutorial, machine learning, tech, and much more. And yeah, drop any question or thoughts in the comment section below. And as usual, keep practicing, stay motivated, happy coding, and see you in the next one.